We now discuss the solution of a problem from the section Coordinate Geometry. This question is related to a line and a circle. This question has appeared in the Joint Entrance Examination Main held on 6th April 2023 in the first shift. The given question is, let the points ordered pair P comma P plus 1 lie inside the region. The region is denoted by E is equal to the set of all ordered pairs x comma y satisfying 3 minus x less than or equal to y less than or equal to under the square root of 9 minus x square, where 0 less than or equal to x less than or equal to 3. If the set of all values of p is in the open interval a comma b, then b square plus b minus a square is equal to. We are given a region E. This is the region E. And the points given, the points P comma P plus 1 lie inside this region. And if P lies in the open interval a comma b, required to find the value of b square plus b minus a square. We now discuss the solution of the problem in detail. The given region is E is the set of all ordered pairs x comma y satisfying 3 minus x less than or equal to y less than or equal to under the square root of 9 minus x square, 0 less than or equal to x less than or equal to 3. Now let's look at the region E. Here you are given 3 minus x less than or equal to y. That means y is greater than or equal to 3 minus x. Now y is equal to 3 minus x is a straight line. Y is greater than or equal to 3 minus x is a set of all points above that straight line. And y is less than or equal to under the square root of 9 minus x square is the interior of the circle, where y square is interior of the circle, y square is equal to 9 minus x square. What is the region E? The common portion that is above this line and the interior of this circle is the region E, where 0 less than or equal to x less than or equal to 3. Agreed. Now the red one is your straight line, y is equal to 3 minus x, and the above one, all points above that line, and y is less than or equal to 9 root of 9 minus x square. If it is equal, it is y square plus x square plus y square is equal to 9. That is the circle with the center at the origin and radius 3. And y less than or equal to another square root of 9 minus x square is interior of the circle. And the common portion, that is this one, is the region. So let's see. So the common portion is this one. The portion is this one. This is the region E. And now it is given the points P comma P plus 1 lie inside this region E. So that means P comma P plus 1 will satisfy the equations, the inequalities that are in the region E. So 3 minus x less than or equal to y will give you 3 minus p less than or equal to p plus 1. And y less than or equal to under the square root of 9 minus x square will give you y means p plus 1 less than or equal to under the square root of 9 minus p square. And 0 less than or equal to p less than or equal to 3. Now let's first of all take the first inequality. 3 minus p less than or equal to p plus 1 will imply 2 less than or equal to 2p will imply p greater than or equal to 1. That means p belongs to the interval 1 to infinity closed at one end, semi-closed interval. Agreed. That's one condition that comes from the first inequality. So let's take the second one. The second one is p plus 1 less than or equal to y. Y is less than or equal to another square root of 9 minus p square. Squaring on both sides and simplifying, we'll get a quadratic equation. P square plus p minus 4 less than or equal to 0. Yeah, less than or equal to 0. So let's take equal to, we'll get a quadratic equation in p. Here it is. Now solving for p is equal to minus b plus or minus under the square root of b square minus 4ac by 2a. And the p value will be minus 1 plus or minus under the square root of 17 by 2. Agreed. So p will be, so p square plus p minus 4 less than or equal to 0 will give you, this will imply p minus alpha into p minus beta less than or equal to 0, where alpha is the first root minus 1 minus root 17 by 2, beta is the other root minus 1 plus root 17 by 2. And remember what we have studied in our earlier classes. P minus alpha into p minus beta less than or equal to 0, then where the p will lie? This will imply p belongs to the closed interval alpha comma beta. Alpha comma beta. Alpha is this value, beta is this value. Right. So the p will be in this closed interval, and from the earlier p belongs to the semi-closed interval 1 to infinity, and 0 less than or equal to p less than or equal to 3, and that will be the interval, closed interval 0 to 3. And the common portion of all this will be p. So this will be p belongs to the first one, 1 to infinity, intersection, this one alpha to beta, the closed interval, intersection 0 to 3, the closed interval 0 to 3. The common portion will be p belongs to that common portion. Agreed. Now, so if you take the common portion, it will be p belongs to the closed interval 1 to beta, that is minus 1 plus root 17 by 2, closed interval. P belongs to this one. You can see on the real number line what happens. This one, the intersection of all these is this one. We continue in the next slide. We have p belongs to the closed interval 1 comma beta, that is minus 1 plus root 17 by 2. So it is given, if p belongs to the open interval a to b, then what will be a? A will be 1, b will be beta, that is minus 1 plus root 17 by 2. So a is 1, b is minus 1 plus root 17 by 2. Yes. The problem is over. We have to compute b square plus b minus a square. Now b square plus b minus a square is equal to b square plus b is 4. How do you know? How do you know? We know because b means beta. Beta is a root of p square plus p minus 4. When b is a root of this one, then b square plus b minus 4 is equal to 0. B square plus b is equal to 4. That is 4. Minus a square, a is equal to 1 square. 4 minus 1 is equal to 3. Did you follow this? So b is minus 1 root 17 by 2. B square plus b is 4. How? B is minus 1 plus root 17 by 2 is none other than beta. And we know beta is a root of p square plus p minus 4. Therefore, b is a root of this one. So, therefore, b square plus b minus 4 is equal to 0. Therefore, b square plus b is equal to 4. 4 minus 1, 3. So, the answer is 3. That's what is wanted in the question. B square plus B minus A square is equal to 3. So the answer is 3. It's a numerical type. Its answer is 3. So that is the detailed discussion of the solution of the problem from the section coordinate geometry, and it is an easy question. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.